Greetings, future mathematicians and circle detectives. I am your professor of perfectly round things, and today we are entering the curvy world of circles. Why circles? Because life without them would be, well, square and very bumpy. We're on slide 1, and we're about to get knowing. Knowing circles isn't just about drawing loops, it's about finding the heart of the shape. Let's start our journey into module 1. Imagine a world where everything was round. Your bed, a circle, your sandwich, a circle, your cat. Actually, cats are already mostly circles. But seriously, circles are the rock stars of geometry. No corners to hit your shins on, no awkward edges, just pure mathematical bliss. So buckle up, or rather, loop in. We're about to dive deep into Module 1, Knowing Circles. It's going to be really good. Slide 2, Circles in the Wild. Look at that bicycle. Those wheels have to be perfect circles, or you'd be bouncing like a pogo stick. And that Ferris wheel? It's basically a giant circle designed to make you see the world from every possible angle of a 360-degree loop. Even the clock face. If it wasn't a circle, the hands would get stuck in the corners. Sorry boss, I'm late because time got caught in a 90-degree angle. See those speech bubbles? They're pointing at the most important part of these circular objects. They all have one thing in common: roundness. Look at the spokes on that wheel. They all meet in the middle, right? That's not a coincidence. It's a structural masterpiece of geometry. Math isn't just in books. It's under your car, on your wrist, and at the amusement park. Circles literally keep our society moving. So, next time you see a wheel, give it a little pat. Say, "Thank you, circle, for being so curvy and efficient." Now, let's look closer. Slide 3, detective work time. We have 4 candidates for the Circle Club. First up, the football. Is it a circle? Tricky. A football is round, but it's a 3D sphere. If you sat on it, it might become a flat circle, but for now, it's just a round ball. Next, the coaster. Now that's a classic circle. Flat, round, and perfect for keeping juice off the table. It's in the club. What about the mirror? Look into it. What do you see? A math genius. And a circle. This one is definitely a member. Shine on circle. And the balloon? Oh, the balloon. It's trying so hard to be round, but it's more egg-shaped or pear-shaped. It's a circle imposter. So, in your head, circle the coaster and the mirror. The football and balloon are roundish, but they aren't geometric circles. Don't let them fool you. The girl on the slide says to find objects in daily life too. Maybe your pizza? Your plate? A coin? Circles are hiding everywhere. I once saw a donut that was a perfect circle until I ate half of it. Then it became a semicircle. Delicious math. Slide 4. This is where it gets interesting. How do we find the exact middle? We fold. Take a circular paper and fold it in half. Crease it good. Now fold it in half again. And again. It looks like a little pizza slice now, doesn't it? My stomach is growling just looking at it. When you unfold it, wow. Look at all those lines. They all intersect at one magical tiny point. That, my friends, is the center. We usually call it point O. Why O? Maybe because it looks like a circle? Or maybe it stands for, oh look, it's the middle. Every fold line divides the circle into 2 equal halves. That's a huge clue. It means those lines are special. We'll name them later. Look at the crow on the bottom right. Even he's impressed. Finding the center is like finding the secret treasure of the shape. Remember, those fold lines have to cross. If they don't meet at a point, you've either discovered a new dimension or you just folded it weird. The center is the commander of the circle. Everything else is measured from right there at point O. It's the king of the round castle. Slide 5. Let's test your eagle eyes. Look at line segment AB. Does it go through point O? Nope, it's just hanging out near the top. Social distancing. It doesn't pass through the center, so it's not a special line yet. It's just a segment visiting the circle for the weekend. But now look at CD. Look at it go. It's like a dot hitting the bullseye. It passes right through point O from one side to the other. High five. Being a center passer is a big deal in circle land. It means that line is perfectly balanced. It's the MVP of segments. Can you spot the difference? Imagine if you had to balance the circle on your finger. You'd want to put your finger right under point O. Line CD would help you. Line AB would make it tip. Math is all about these little rules. Passes through or does not pass. It's simple, but it changes everything for our round friend. Slide 6. It's consolidation time. That's a fancy way of saying, let's make sure our brains aren't leaking. Take out your circular paper. Seriously. Fold it twice, unfold, then repeat it with a different pair of lines. It's like origami, but with more math and fewer paper cranes. Do the fold lines cross at the center? Yes, they always do. It's like they're being pulled by a magnet to that middle spot. It's inevitable. You can try this 100 times with different angles and it will always work. Math doesn't lie, and it doesn't take days off. This proves that the center is unique. There's only one point O in every circle. It's a very exclusive club of, well, one lonely but important point. Slide 7, preview time. Measure the length of each fold line on your paper. What do you discover? Go ahead, I'll wait. Okay, I won't wait that long. They all have the same length, every single one. It doesn't matter which way you fold it. As long as it goes through the center, it's the same size. This is a huge discovery. It means circles are incredibly symmetrical. Next time, we're going to give these lines their official names. Spoiler, they're cool. You've finished part 1. You found the heart of the circle and discovered the secret of the same length folds. You're basically a math wizard now. But don't stop here. We've got 5 more videos to go. The world of circles is about to get even bigger, faster, and rounder. See you in part 2. Welcome back, circle stars. I hope your brains are ready for more roundness. Today we're learning the official names of circle parts. No more calling them the line or the edge. Look at slide 8. The perimeter? That's the circumference. It's a long word, isn't it? Try saying it 3 times fast while spinning in a circle. Actually, don't. You'll get dizzy. And that line passing through the center from side to side, that's the diameter. It's the big boss of lines. It divides the circle perfectly. It's the MVP. Slide 9. Let's get our rulers out. We've got diameters AD, BE, and CF. They all go through point O. If you measure them, what do you see? They're all 3 centimeters. Coincidence? I think not. It's a mathematical law. Every diameter in the same circle is exactly the same length. It's like they're identical triplets. Slide 10. The bird has spoken. All diameters of a circle have the same length. If you find one that's shorter, you've either found a broken circle or a very weird potato. Slide 11. Now meet the little brother of the diameter, the radius. It goes from the center to any point on the edge. It's like a spoke on a bicycle wheel. Think of the center as the sun and the radii as sunbeams. They reach out and touch the edge of our circular world. How many can you draw? Infinite. Slide 12. Rulers again. OA, OB, OC. They're all 1.5 centimeters. Wait. 1.5 is half of 3. Do you see the secret connection between radius and diameter yet? Just like the diameter, all radii in a circle are the same length. They're like a team of perfectly matched gymnasts, all reaching out to the same distance. Slide 13. Here's the magic formula. Diameter is 2 times the radius, or radius is diameter divided by 2. It's the most important relationship in circle land. If the radius is 10, the diameter is 20. If the diameter is 100, the radius is 50. It's so simple, even my pet parrot could do it, if I had a parrot. Slide 14. Let's play a fair race. Look at the 3 methods. If you're the blue dot and you want that green flag, which arrangement is the fairest? Method 1, some people are closer. Method 2, the corners are way further away. But method 3, everyone is at the exact same distance. Why? Because they're on a circle. That's the power of the radius. It makes things fair. Circles aren't just shapes, they're the ultimate tools for fairness and balance. Who knew math could be so heroic? You've mastered the big 3, circumference, diameter, and radius. Next time we're going on an investigation to find the longest line possible. See you in part 3. Welcome back, math detectives. We are on a mission to find the biggest line. No, not a fishing line, a geometric line segment inside our favorite shape, the circle. Look at slide 15. We have candidates A, B, and C, and of course, our old friend, the diameter. They're all joining points on the circle. But which one is the heavyweight champion? Is it segment A, looking all green and lean? Or segment B, the blue bolt? Or maybe C, the orange underdog? Let's put them to the test. It's time for inquiry and investigation. Slide 16. Here is our lab report. We measured them all with a super precise mathematical ruler. Look at the numbers. Diameter is sitting pretty at 6 centimeters. Segment A, only 4.5. B, getting closer at 5.2. And C, a respectable 4.7, but none of them can touch the 6 centimeter glory of the diameter. It's like comparing a mouse to an elephant. The diameter is the only one that passes through point O. Coincidence? I think not. Passing through the center gives it that extra length boost. It's like having a superpower. Slide 17. Let's have a chat. Question 1. Which line segment is the longest? Drumroll, please. The diameter. It's the king of the mountain. All other lines are just peasants. Now question 2. Can you draw a line segment joining any 2 points on the circle that is longer than the diameter? I'll give you a second to think. Cannot. Absolutely not. If you try to draw a longer line, you'll end up outside the circle, and then you're just drawing in the air like a crazy person. The diameter is the maximum, the limit, the ultimate length. Slide 18, the conclusion. Read it with me. Among the line segments joining any 2 points on a circle, diameters are the longest. Case closed, mystery solved. Let's celebrate with some round cake. Look at that bird on the slide. He's so happy because he knows the truth now. He's a diameter believer. You've just completed a major investigation. You're basically math scientists now. That's all for part 3, my amazing circle detectives. You found the longest line and debunked the imposters. But wait, how do we actually measure these things when they're stuck inside squares? Next time, we're going to look at some consolidation exercises and find the diameter's position in tricky situations. Don't go anywhere. Part 4 is just around the curve. See you then. Welcome back, circle superstars. Are you ready to flex those mathematical muscles? Slide 19 is our first test. Look at line PR. Is it a diameter or a radius? It crosses the center, so it's the big boss diameter. And OQ, just a halfway hero radius. Boom. Remember, the radius is like the diameter's mini-me, always starting at point O and heading for the edge. It's half the size but double the fun. Circle those answers like a pro. Slide 20. Multiple choice madness. Which of these segments have the same length? OA, OD, and OE are all radii. They're like a matching set of geometric socks. They have to be the same. FB and EF? Those are just random lines trying to fit in. Ignore the imposters. Slide 21. Detective hat on. Which line is the longest? ST, SU, or TV? Look for the one passing through point O. TV is the winner. It's the diameter, the undisputed heavyweight champion of circle lengths. Accept no substitutes. Slide 22. Time for some mental math. Point J is the center. If radius JB is 4 centimeters, how long is diameter AD? 2 times 4 is 8. It's math magic. You're basically a calculator with a better personality. Slide 23. Fun fact time. Ancient scholars thought circles were sacred and perfect. I mean, look at them. No corners, no drama, just smooth vibes. They even used giant compasses. Talk about a high-stakes drawing lesson. Slide 24. How do you find the center of a circle without folding it? You trap it in a square. Use your rulers and set squares to hug the circle on all sides. Every line must touch the edge. It's like building a little geometric fence for your round pet. Slide 25. Once you've got your square, draw the diagonals from corner to corner. Where they cross is point O, the center, and the side of the square. It's exactly the same length as the diameter. Math is so efficient, it's almost suspicious. Final challenge on slide 26. Measure the diameter of this trapped circle. It's 3.8 centimeters. Mark that center point O right where those red lines cross. You've just mastered the professional way to measure a circle. Precision is your middle name now. You've finished part 4. You're measuring circles like a pro and using squares to find the truth. Next time, things are going to get even more triangular as we look at shapes formed with circles. Don't miss part 5, it's going to be sharp. Welcome back, shapeshifters. Part 5 is here, and things are getting pointy. We're looking at triangles and quadrilaterals hiding inside our circles. It's like a geometric game of hide and seek. Look at triangle XYZ. Point X is the center. That means XY and XZ are radii. And what do we know about radii? They're equal. So XYZ must be at least an isosceles triangle. Math logic for the win. Slide 28. Triple trouble. 3 identical circles meet. Points A and B are centers. The distance from A to the meeting point is 2 centimeters, and from B to that point is another 2 centimeters. So AB is 4. Easy peasy. Slide 29. Same logic for side BC. 2 radii of 2 centimeters each join forces to make a 4 centimeter side. It's like the circles are holding hands to build a triangle. 2 plus 2 equals 4. My brain is on fire. Slide 30. And side CA? You guessed it. 4 centimeters. It's a 4 to 4 4 triangle. Do you know what that means? It's not just a triangle. It's a special kind of triangle. Any guesses? Slide 31. It's an equilateral triangle because all sides are equal. When circles of the same size hang out, they create perfect symmetry. Isn't geometry just beautiful? And very organized. Slide 32. Now things get really interesting. 4 circles. 2 large, 2 small. What kind of shape is ABCD? It looks like a diamond, but we need the mathematical name. Let's investigate the side lengths. Slide 33. Side AB is made of 1 radius from a small circle, 3 centimeters, and 1 from a large circle, 4 centimeters. 3 plus 4 is 7. AB is 7 centimeters long. Remember that number, it's important. Slide 34. Side BC. 1 large radius plus 1 small radius. Still 7. It's like a magic trick where the answer is always the same. 7 centimeters again. Who would have thought? Slide 35. CD? 3 plus 4 is, wait for it, 7. I'm starting to see a pattern here. Are you? Every side is 7 centimeters. It's like a club where the entry fee is exactly 7 units of length. Slide 36. Final side DA. 4 plus 3 is 7. Every single side of ABCD is 7 centimeters. 4 equal sides, but are there right angles? Look closely. No. So what do we call this tilted square? Slide 37. It's a rhombus. 4 equal sides, no right angles. It's like a square that's leaning over to whisper a secret to the circles. Hey circles, thanks for making me so equal. Slide 38. One last check. 2 identical circles, centers B and D, radii are 3.7 centimeters. All sides AB, BC, CD, and DA are made of these equal radii. So it's another rhombus. You're a rhombus recognizing machine. You've conquered the complex world of shapes inside circles. You know how to add radii to find side lengths and identify triangles and rhombuses like a master. Great work, everyone. Next time, we face the ultimate challenge, the rectangle challenge. Can you calculate lengths when multiple circles are trapped in a box? Find out in the final part 6. See you there. Welcome to the grand finale, Circle Champions. We've reached part 6, the ultimate test of your roundness knowledge. Look at slide 39. 5 circles trapped in a rectangle. It's a geometric jailbreak. Each circle has a diameter of 4 centimeters. They're all lined up like passengers on a very round bus. How long and wide is this rectangle? Don't just guess. Use your circle logic. Think about the diameters. Slide 40 reveals the secret. Look at the width WV. It spans 1, 2, 3 diameters. 4 plus 4 plus 4 is 12. And the height UV? That's just 1 diameter. 4 centimeters. The rectangle is a 12 by 4 masterpiece. Slide 41. A 3-circle party. Radii are 3, 4, and 5 centimeters. To find the perimeter of triangle ABC, we just add the pairs of radii. 3 plus 4, 4 plus 5, and 5 plus 3. That's 7, 9, and 8. Total 24. You're adding like a boss. Slide 42. The ultimate challenge. Are high and BD equal? Yes, because high is the side of the big square, which is exactly the same as the circle's diameter. And BD? It's a diagonal passing through the center. Diameter equals diameter. Logic prevails. Slide 43. Exercise time. Mark that center point O. Now measure the radius. It's 1.6 centimeters. Quick, what's the diameter? 3.2. See, you're doing it automatically now. You're unstoppable. Slide 44. VR and VS are both radii, so they must be equal. And which line is the longest? RT. Why? Because it's the only one passing through the center. The diameter always wins the length contest. It's the law. Slide 45. OD is the radius, AB is the diameter. So AB is 2 times OD. Simple. And look at triangle ACD. CD is shorter than the diameter AB. The diameter is the king of lengths, remember? No exceptions. Slide 46. Bella's trick question. A 4 centimeter line from the edge to a point inside. It may not be a radius. To be a radius, it must end exactly at the center. Don't let Bella fool you with her random points. Stay centered. Slide 47. The final battle. Overlapping circles with radii of 10 cm. ABC is an isosceles triangle because 2 sides are radii of 10 cm. The perimeter, 10 plus 10 plus 10 plus... Wait, look at the diagram. It's 40. A perfect finish. You've done it. 6 videos, 47 slides, and a whole lot of roundness. You are now official circle masters. You know the heart, the parts, and the logic of the most perfect shape in the world. Go forth and find circles in the real world. Measure them, fold them, and always remember, keep rolling with math. I'm your funny professor, signing off. See you in the next module. Goodbye.